Welcome to this activity, which is about evaluating definite integrals. So we have different kinds of integrals. Let's compute them. The first one is the integral between 0 and 10 of 4 dx. So we're going to compute the antiderivative of 4, which is 4x, without the constant, because if you take into account the constant, it's going to be cancelled. So you don't need to put the constant. And between 0 and 10. Now you evaluate this antiderivative at 10 minus the value of this antiderivative at 0. So it's 4 times 10. We'll do it slowly. Minus 4 times 0. So it's going to be equal to 40. Second one, it's the integral between minus 2 and 2 of x cubed plus 7x. So you need to compute the antiderivative of x cubed plus 7x. And the antiderivative, or the indefinite integral of x cubed plus 7x, is x to the power of 4 over 4 plus 7 times x squared over 2, taken between negative 2 and 2. In general, we have to make this computation, but in this case, you don't need to make any computation, since you can see here that the powers of x are even powers. So they give the same value at 2 and minus 2. So if you evaluate this function at 2 and minus 2, you will find equal quantities. Since you will make the difference, the result is automatically 0. Okay, because the value of this function at 2 and minus 2 is the same. Okay, now the third integral, which is the integral between 6 and 6 of x squared minus 5x plus 1 to the power of 10. And here again, you don't need to make any computation, since the bounds are the same. So a equals b in this case. Okay, so it's automatically equal to 0. Fourth one, the integral of 2 over square root of x between 4 and 25. So first of all, we have to compute the indefinite integral between of 2 over square root of x. So we have to write it as a power first. So x to the power of negative half dx, which is equal to 2. And here you make the integral of x to the power of negative 1/2 using the power rule. So it gives x to the power of 1/2 over 1/2, okay, taken between 4 and 25. It's equal to 4 times, and here I will write the x to the power of half as square root of x between 4 and 25. So it's equal to 4. Square root of 25 is 5, minus square root of 4 is 2. So the result is 4 times 3, which is 12. Next one, the integral between 2 and 3 of 12x times x squared minus 4 to the power of 5. We can, of course, here use integration by substitution, since it's of the form u prime u to the power of n. So this is u. U prime is 2x. So we have to show 2x in front of u to the power of n. So we need 2x. And since we need 2x, we will put 6 outside of the integral. And we're going to write 2x times x squared minus 4 to the power of 5 dx. And here you can see clearly the form u prime u to the power of n. So it's equal to 6 u to the power of n plus 1. It means x squared minus 4 to the power of 6 over 6 taken between 2 and 3. Sorry, I didn't write it here. So between 2 and 3. And of course, you can cancel the 6. It gives x squared minus 4 to the power of 6 between 2 and 3. At 3, it gives 9 minus 4, which is 5, to the power of 6 minus 2 squared, which is 4. 4 minus 4 is 0 to the power of 6 is 0. So it's 5 to the power of 6 minus 0, which is 5 to the power of 6. Next one. The integral between 0 and 1 of x exponential minus x squared. So let's try integration by substitution first. Remember that the integral of u prime exponential u is exponential u. So if I take this as u prime is minus 2x, and I have x here, so I need a minus 2. So I will multiply and divide by minus 2 to get this integral. So it's equal to minus 1 over 2 times the integral of minus 2 x exponential minus x squared dx. And here you can see clearly u prime exponential u. So you can compute this integral. It's between 0 and 1, sorry. It's minus 1 over 2. And the antiderivative of minus 2x exponential minus x squared is exponential minus x squared, taken between 0 and 1. And you can write it as minus 1 over 2. And you evaluate this function at 1, which gives e to the power of minus 1, minus the same function at 0, it gives 1. And of course, you can manage your expression or simplify it if you want. So we can write it as 1 over 2 times 1 minus 1 over e if you want. Okay? Next one, number 7. Again, here you see that a equals b, so automatically it's equal to 0. Next one. The integral of ln of x squared over x. Again here, I said previously in the previous videos that if you see an ln inside an integral, try to find the 1 over x, which is its derivative. Yes, here we have 1 over x, so we can write this integral as the integral between 1 and e of 1 over x times ln of x squared dx. And here, this is u prime, this is u, and to the power of n. So we can write it as the integral, or we can compute its antiderivative directly now. It gives u to the power of n plus 1 over n plus 1. So it gives ln of x to the power of 3 over 3 between 1 and e. Now, ln of e is 1. So at e it gives 1 cubed over 3, which is 1 over 3. And at 1, ln of 1 is 0. So 0 cubed 0, 0 over 3, 0. So 1 over 3 minus 0, which is 1 over 3. Next one. The integral between 1 and e of ln of x. Here, if you have the formula in mind, you can directly use it. But if you don't know what is the integral of ln of x, you have to compute it. And you can compute it using integration by parts. And I need to write a hidden one here to set it as u prime. Okay? So let's compute this integral by integration by parts. So let's take u prime equals 1. And v equals ln of x. So if u prime is equal to 1, mu is equal to x. And if v is ln of x, v prime is 1 over x. Okay? And you apply the integration by parts. So it gives, let's compute the indefinite integral first, and then we'll compute the definite integral. So the integral of ln of x dx is equal u times v. It means x ln of x minus the integral of u times v prime. It means x times 1 over x, which is 1 dx, which gives x ln of x, and the integral of 1 is x. Of course, you can put plus c here, but it doesn't matter since we don't need the c in the definite integral. So it's the integral between 1 and e of ln of x dx is equal to the function x ln of x minus x taken between 1 and e. So let's evaluate it at e. It gives e times ln of e. It means e times 1. So it's e minus e. So it gives 0 at e minus 1 times ln of 1. It means 1 times 0, which is 0, minus 1. Okay? So at the end, you're going to obtain 1. Okay? Next one. The integral between 0 and 1 of 5x exponential minus x dx. Again, here, we try to think about integration by substitution. So if I take this as u prime is minus 1. But instead of minus 1, I have 5x. And I can't get rid of this x. So the integration by substitution doesn't work. I have to think about integration by parts. And I will take u equals exponential minus x and v equals 5x. U prime, sorry, it's u prime here. So u is equal to minus exponential minus x by integration. And the derivative of 5x is v prime equals 5. So use the integration by parts to compute the integral of 5x exponential minus x dx. It's u times v, so minus exponential minus x times 5x, so it gives minus 5x exponential minus x minus the integral of u times v prime, which is minus 5 exponential minus x. With this minus sign, it becomes 5 exponential minus x dx. And here it gives minus 5 x exponential minus x. Again, here, the integral of exponential minus x is minus exponential minus x multiplied by 5. It gives minus 5 exponential minus x plus c. Okay? Now, for the definite integral, it's taken between 0 and 1. The integral between 0 and 1 of 5x exponential minus x dx, it's equal. Of course, we can put the exponential minus x and the 5 as a factor here, so we can write it as, we'll put the minus 5 outside, and you will obtain here exponential minus x factor of x plus 1 taken between 0 and 1. So you can evaluate. So it's equal to minus 5 times, and this function at 1 gives exponential minus 1 times 1 plus 1, which is 2, minus the value of this function at 0 gives exponential minus 0, which is 1, times 0 plus 1. So the final result will be 1 minus 1. So at the end, you can write your expression as 5 times 1 minus 2 over e. I hope that it was clear. Thank you for your attention and see you in the next videos.